Hello again. This is the Module 3 review. This is page 55 in your workbook. A blank is the y-coordinate of a point where a graph crosses the y-axis. And if you've tried these before, go ahead and check them. This is the y-intercept. Crosses the y-axis. A blank is the y-coordinate of any point that is the highest or lowest point for some section of the graph. So this is a relative minimum or maximum. High and low, or low and high. A blank is the x-coordinate of a point where a graph crosses the x-axis. That is called the x-intercept. A figure has blank if there is a line that divides the figure into two halves that are mirror images of each other. This is line symmetry, or line of symmetry. Blank describes the appearance of a graph as it extends in both directions away from zero. That is its end behavior. A figure has blank if it can be rotated less than 360 degrees around a point to coincide with itself. That is rotational symmetry. And that's a review of the vocabulary. Number 7. Which of these graphs is 2x plus 2y equals 6? Which of these graphs is 2x plus 2y equals 6? So let's write the function. And the easiest way that I can tell you to do this, there are other ways than this, but this is what I would do. I would find my intercepts, because these graphs clearly give us intercepts. So that's a surefire way of finding it. And I like to find the y first because it's usually easier to do. Not always, but usually. So this is 2x plus 2y equals 6. And I want to solve this equation for y. Alright, and I don't know what I'm doing. That needs to go through equals. So I want to get y on this side and everything else on this side. Okay, let me zoom in as much as I can so you can. Alright, so we're going to move the x term off of this side and on to this side. So this will cancel. And so I'm left with 2y equals 6 minus 2x. And then I'll divide by 2 to get y by itself. And that will be the answer that I need. So y, I know this is bizarre looking, guys. Just hang with me here. 2x divided by 2. Now, if we want an intercept, let's let x be 0. So y equals 6 minus 2 times 0 divided by 2. So y equals 6 minus this is 0 right here. So 6 minus 0, that's 6 divided by 2. Y is 3. So when x is 0, y is 3. Now let's see if one of these graphs fits. Okay. There is 0, 3. Here is 0, 6. Here is 0, 6. And here, be careful, it's tempting, but this is 0, 2. So which graph matches what we found? 0, 3 and 0, 3. I would go with graph A. If you can find those intercepts, that will help you. All right, number 8. They want me to graph this thing, at least one possible solution. This is not the only one. But they tell me that the x-intercepts are -3, -1, 1, and 3. And if they're x-intercepts, the y is 0. So there are 4 points right off the bat. And then this one is a y-intercept, so x would be 0 and y would be -9. So those could be, I'm not even going to copy them in there, those are the table of values. So let's graph these points. We have a -3, 0. So that's right there. A -1, 0. A 1, 0. A 3, 0. And then a 0 down to 9. So down here. So this is a peculiar looking thing so far. There is one relative minimum at -9. It occurs at that one point, so we've got that down there. There is one relative maximum at 16, and it occurs at 2 points. So I'm going to have to count up here to 16. That's up here. I need to read a little bit more though to know exactly what to do at 16. The graph extends endlessly in both directions. So it's telling me that this has end behavior that is the same. That makes me think of a parabola, but this doesn't look like a parabola. The graph is symmetrical about the y-axis. So the y-axis is the mirror. So that tells me that here at 16, I need to put a point on this side and a point on this side. And the maximum occurs at 2 points. So that's what's going to make this symmetry. And here's what they're looking for, guys. This is a funny looking graph to me. It's going to be this way, down through this one. Oops, I messed it up. Sorry, I may have to do it in parts. It's kind of a weird, wonky, scary M shape. Okay, so we've got that end behavior. It's something like that. And their picture is much better than mine. But that fits the description of those elements of a graph. Again, don't worry about this one. You are not going to have to draw this on a test. All right, number 9. Which situation is best represented by this graph? And by the graph, I am referring to this one that you see right here, where we have height and time. And before I look at my choices, here's what I want to make sure you realize. That this is an increasing interval. And then we get a constant interval. And then we get a decreasing interval. So whichever story I pick to go with this graph has to follow that concept. All right, so A says a rubber ball is dropped from a height of 5 feet. It bounces several times before rolling to a stop on the ground. So somebody's here at 5, they drop this ball, it's going to fall, and it bounces several times before rolling to a stop. That is not what this picture is showing me. An elevator begins at the ground floor of an office. It goes up 3 floors and remains on the 3rd floor for several minutes. It then goes down to the 2nd floor, then up to the 5th floor. So that's not the same motion. We're looking for that general flow of motion that matches. Leanne hikes up to a mountain peak at a speed of 2.5 miles an hour. So she doesn't just go straight up. If you're hiking up a mountain, you're going to go like that. She reaches the top, she rests for a while, and then she hikes back down at a faster pace. That looks kind of familiar. But let's look at D. A diver is on a board 1 meter above the ground. So here he is up here on this board. He dives into a pool that is 12 feet deep and then swims up to the water's surface. The only one of those that is even remotely close to what I'm looking at is C. I've seen these a lot, guys, on the science test. I didn't have to do any math. It's science reasoning that they're testing there. All right, number 10. We are given this graph and we're asked to identify these pieces. And I tell you what I'm going to do if I can. No, I can't. All right, so the x-intercepts of this graph. I see 3 of them. They're those red dots. I see one at -1, 0, 1, 0, and 3, 0. So -1, 0, 1, 0, and 3, 0. And the true intercept is just the x value. So the answer to this question is -1, 1, and 3. All right, the y-intercept is this green dot. And it kind of looks like it's on 4, but it's not. It's a little under there, so I'm going to call it 0, 3. So 0, 3. And the true intercept is just that value. of 3. Increasing intervals. In other words, where is that graph climbing? So it's climbing obviously right there. So once x is greater than 3, the graph is climbing. So x is greater than 3. I see another interval where it's climbing. Actually, do they want me? Yes. Hold on, guys. Let me be sure that I'm telling you correctly, because I don't agree with what they're saying here.